Okay guys, so the last time we found the equation of the curve. That's part one of the question. And now we're asked to find the coordinates of the stationary points, right? Alright, so recall that stationary points are at dy by dx equals 0. Right? We are given dy by dx, that is 3x squared minus 6x. So at this point where it's equal to 0, we can find the stationary points. If we should factorize, then we end up with 3x times x minus 2 equals 0, which implies that x is going to be equal to 0 and x is also equal to 2. Alright, now that we have our x values, we need to find our y values, and that is simply by plugging in our x values in the equation, right? We already found the equation in the previous video where we integrated. So let us use the equation. So this was our equation. The values of x we're looking at are x equals 0 and x is equal to 2. So y is equal to 0 cubed minus 3 times 0 squared plus 4, and that is when x is equal to 0. So that means y is equal to 4. When x is equal to 2, y is equal to 2 cubed minus 3 times 2 squared plus 4. Right? So that's 8 minus 12 plus 4, which is 0. So that means that the coordinates for the stationary points are going to be 0, 4 and 2, 0. So that is it for part 2. Let us pause for a cause. Okay, so part 3 of the question says determine the nature of each stationary point. Right? Now we can use the second derivative to determine the nature of a stationary point. If the sign of the second derivative, that is d squared y by dx squared, is negative, then it's a maximum value. If the sign of the second derivative is positive, then we'll obtain a minimum value. So that is if this d squared y by dx squared is greater than 0, then we have a minimum. If d squared y dx squared is less than 0, we have a maximum. Okay? Alright. Alright, so let us go ahead and find our second derivative. So remember, the dy by dx is 3x squared minus 6x. dy by dx is 3x squared minus 6x. So d squared y by dx squared is going to be 6x minus 6. Right? When x is 0, d squared y dx is 6 times 0 minus 6, and that is negative 6. So in this case, the second derivative is less than 0, and so at the point 0, 2, therefore at 0, 2, we have a maximum, right? When the second derivative is less than 0, we have a maximum. When x equals to 2, then the second derivative is going to be equal to 6 multiplied by 2 minus 6. So that's 12 minus 6, which is 6. So at this point, two at 2, 0, we have a minimum. The nature of the stationary point will be a minimum one. Alright, so we have answered part 3 of the question. Let's take a look at part 4. It says find the coordinates of the points P and Q at which the curve C meets the axis. Okay, so for that question, we look at in another video. Thank you for watching. I hope you learned something.